Okay, so we have one more talk about AI, but more, I guess, on the JavaScript side, right? Yeah, I remember UK was giving AI talk on one of my first VanJS around 3 years ago. He was doing it before AI was too hype, so he was definitely one of the first one giving AI talks at VanJS. So welcome, Mikey.
And here as well, who here uses Claude code? Perfect. Some of you. I'll just assume that everyone's familiar with Claude code. Who here is not familiar with Claude code? At least the concept. One person. So a couple people. So basically, it is an agentic application that you can use on the terminal mostly, where you can ask any questions about the code base. You can ask it to perform different actions like do web searches, write code, run tests, stuff like that. Any sort of CI jobs or CLI commands as well. So that's the basics. And just making sure everything's fine, recorded. And I know that one of the other speakers is going to talk about from the schedule, AI Engineer Conference, AI Code, right? Yeah? In New York. Did you go to New York?
Yep.
Nice. That's really cool. So I figure that's like a good place to start. Just to kind of introduce myself. And how much time do I have for this? 10 minutes. Perfect. I'll try to fit everything in time. I'll see. I'll do my best. Maybe we can skip questions if I go over time a little bit. So in 2024, I went to San Francisco and spoke at an AI engineer conference. The same organizers in different events in San Francisco. That was me. It's not necessarily the best picture of me giving a talk, but this was a talk about AI for coding. So that was 1.5 years ago. And in 2023, 2.5 years ago, in Vancouver, I gave another talk about AI for coding. So this is just to demonstrate and illustrate that I've been talking about this topic for a while now. More recently, I created this GitHub repo. I think it was a few months ago, where I share my Claude code tips in particular, and it has a bunch of stars now. And that's why I'm going to speak about this topic in particular. So, as you can see, this talk is called Automatically Patching Claude Code to Maximize Token Efficiency. And there's going to be a lesson in automation as well. The original motivation I had as I started to use Claude Code, pretty intensely over the past basically 11 months, but very recently, I noticed that whenever I start a conversation, it would automatically use up 10% of the tokens, 20,000. So I thought that was kind of wasteful. I wanted to cut it down to about 5%. That's exactly what I did. And you might say, oh, why not cut it down to 2%, 7%? It's, at the end of the day, a matter of trade-offs. It's a matter of how many tokens are you willing to tolerate at the beginning of the conversation, and how much information are you willing to lose from the simplified instructions. And one sort of unscientific way I think about it is the original instructions, the initial context. If you started at 10% of the 200K context window for Opus 4.5, it's almost as if you're planning a 30-day trip, a 1-month trip, and you spend 10% of that 3 days on planning alone. And that seems a little bit excessive. If you spend 1 or 2 days, that seems more reasonable. 1.5 days, that's 10%, that's 5%. So that's sort of how I decided on this number. And as a result, starting from the result, I was able to cut it down to 5%, like I said, and the performance has been pretty good. It made certain mistakes. The behavior changed because I changed the system prompts and the tool descriptions. But overall, it worked well. And for the behavior that changed that I didn't like, I was able to tweak it a couple times And since then, it's been performing pretty well, even though it was cut down to about half of the original. And if you think about how you would go about it, you might say, okay, I can think of a few different solutions. If you're familiar with it, you might say, oh, I can just use this flag, system prompt or system prompt file flag, and then change the system prompt directly that way. And that works for the system prompt portion of the starting tokens, but it doesn't work for the tool descriptions, which are actually much longer than the system prompt. So I decided to go with the more direct approach of patching the Minified CLI bundle. Now, when you think about different ways of downloading and installing Claude Code, there are two main ways, NPM and native binary. I decided to go with NPM because that's how you can get access to the Minified CLI bundle. So I took a look at the CLI bundle, and they have a little Easter egg. They say, if you want to see the unminified source, we're hiring, they're hiring. So I guess if you want to see that, you should apply through that link. Now, I came up with the 4-step process for achieving this. For the first step, I asked it to simply self-report what it sees in its own system prompt and tool descriptions. And I said, what does that look like? And it's able to describe that just to see the structure. And I asked it to identify the potential biggest savings. In this particular conversation, I was upgrading the existing patches, so I was able to see what the current patches look like and what the potential additional savings could look like, for character counts and token counts. It's not always 100% accurate, but it gives you a rough idea. And then I had it write the actual JavaScript code. So apply the patches to the Minified JavaScript code, and then I had it test to make sure it works. One way I had it do it is I had it run an instance of Claude Code in a container, and I had it talk to Claude Code itself to test everything on its own, so I don't have to test it manually. Now, how the upgrading process evolved is it started as a manual process, mostly manual process where I would manually prompt Claude Code to write these patches whenever there's a new version of Claude Code. But that was a pretty painful process because they had basically like a daily update, except for the Christmas break. So I needed to ask it every time there's a new version to update it and troubleshoot it, and that was a pretty painful process because it's not meant to be used that way. So I decided to put all of these issues that I ran into and these instructions into a single file called upgrading.md. And I kind of think of it as an onboarding document for a new employee who doesn't know anything about this project. It describes what this project is and which files to look at and how to go through this whole process whenever there's a new version of Claude Code. And that was actually really helpful. And I also added a self-improvement clause to this document so that if there is anything that it can do to improve the process itself, it's allowed to change the file content itself so that the next agent can do it better. Now, that's how I did it, but I wanted to draw a larger lesson in automation in general because I think that would be more applicable to more people here. And that is that it's really powerful when you're able to combine deterministic and non-deterministic automation. So for the non-deterministic automation part of this process, I used, like I said, the upgrading document so that I'm able to give it structured and consistent instructions to Claude Code, which is a non-deterministic system. And for the deterministic part, like I said, I created the patching script. I called it patch CLI.js. That was able to deterministically apply these patches every time there's a new version of Claude Code. And as you can see, this is a general process that you can apply to pretty much any automation project. If you want to automate something, then you can think about which parts can be done through deterministic automation, non-deterministic automation. Sometimes you can improve the code base itself if you have access to the code base. And I wanted to quickly cover two more examples of the general automation lesson. One is the CI job analysis, which I have talked about before, where I joined this project this open source project called Daft several months ago, and I found myself struggling with their GitHub action failures because they would happen often, and I would need to manually prompt Claude code to fix it for me or like troubleshoot for me. So I wanted to kind of simplify that process and give it structured prompts. And for that, I created a slash command, which is basically a bundle of these prompts, kind of like the operating documents. And I would use this system. And on top of this, I wanted to automate the process of fetching messages from Slack, like these GitHub action failure notifications, so that I don't have to copy these failure links to and paste it to the GHA command manually. So for that, I created a JavaScript script, Slack.js, that would basically be used for reading these messages and giving them to GHA command. And this was a deterministic part of the automation. And same thing with this other project that I started recently at work. It's more of a local Kubernetes development. I was onboarded as one of the later team members, and I wasn't familiar with local Kubernetes development at all. So I struggled a lot, just contributing to the code base, setting up my development environment. So I wanted to automate that whole process. The way I went about it was, first I fixed some of the code base because there were bugs in the code base itself, and then I started to kind of put structured instructions in Claude MD, so Claude Code knows like what to do without me having to tell exactly the same instructions over and over again. And I also created more of a deterministic script that would help me understand the health of the system. So it was a combination of improving all of these different processes. And that's how I was able to gain more confidence to contribute to this project that you see here, so that we're able to move faster as a team. Now, I want to close this talk with one or two things here. The first one is the automation meta lesson. As you saw here, the key is to first identify, is there something that you find boring, that you don't want to do, that's really painful manually? And second, which parts can be automated in a deterministic way, which parts can be automated in a non-deterministic way with AI, and which parts are more of general code-based improvements. And then go through the process over and over again until it's really smooth. And final thing, the final reminder I want to leave this talk with is to not over-automate, because it's really tempting, especially as a software engineer, to put in like a lot of instructions in Claude MD and maybe create lots of skills, create 100 sub-agents and stuff like that. But oftentimes, keeping it simple is the right solution. So I'll leave this talk at that. If you want to find some of the source code I mentioned, it's on the left. And if you want to find my LinkedIn, it's on the right. Thank you so much.
Thank you very much, Artie. It's always good to remember that best is the enemy of good. So always try to balance it, as YK mentioned, and we have time for 2 more questions.
So such optimizations, sometimes it's great, sometimes it's not, but I'm wondering about the specific achievements what you achieved by this. Like, you optimized something and what the benefits you got out of it, right? The context is now less populated, but what for? Like, did you notice actual improvements in your workflow because of this?
So when you look at the performance, I haven't noticed any particular difference. The big thing for me that's very noticeable is the fact that you start at lower context, so you can start, you can continue the conversation slightly longer.
One more question?
The best job here, running around the conference room. Maybe it's a fun question. So you mentioned don't automate too much or everything. Kind of intuitively understand why, but were you able to measure it somehow? When you over-automated and it broke?
So I think this is like a classic software engineering thing where you spend like 5 hours automating a 5-minute task. And I think like,
Which
to
you're gonna
me-
do once.
Huh?
Which you're gonna do once in your lifetime.
Yeah, exactly. To me, the way to measure it is how often do you encounter it, how many people encounter it, and how much time does it take to automate it. And you don't necessarily always have to like measure everything kind of in a scientific that way. If you're more of an intuitive person, it's like how painful is it? How annoying is it? Like if it's annoying enough, then you automate it.